In this video, we're going to be doing a Unit 2 Forces Circular Motion MCQ practice. So for our first question, we have a 2.0 kilogram mass moves in a horizontal circle of radius 1.5 meters with a speed of 6.0 meters per second. What is the centripetal force that is acting on the mass? The object has a centripetal force that is keeping it moving in a circle. So our radius is going to be 1.5 meters. And its speed is 6.0 meters per second. So you have to use your centripetal force formula. Fc is equal to mass times velocity squared over your radius. So your mass is 2.0, your velocity is 6, and your radius is 1.5, so this is going to give you 48 newtons. A car travels around a flat circular track of radius 50 meters at a constant speed of 20 meters per second. What is the magnitude of its centripetal acceleration? So if we're going around a flat circle, we can draw this out too. So the radius is going to be 50 meters, and your constant speed is 20 meters per second. So we want to find the centripetal acceleration of this car's track. AC is equal to velocity squared over your radius. And this is the formula you're always going to use. So AC is equal to 20 squared divided by 50. So that's equal to 8 meters per second squared, which is going to be B. A ball is tied to a string and swung in a vertical circle. At the top of the circle, what forces act on its center? So we're looking at when it's at the top. And we're swinging this object in a circle at various points in time. So how do we find this? When the ball is up here, what forces are acting on it? So when it's up here, wherever you are on Earth, you always have the force of gravity. But in this case, we have a centripetal force that is going to be pointing to the center of the point of your hand. So your hand is here. So let's say that's my hand. That's my hand, and it's spinning it like that. You have your force of gravity that's acting down, and you also have your force of tension, which is acting down as well. Your tension force is just your spring, your string of your ball. So your centripetal force is toward the center. Your center is downward. Both forces are going to be downward. So that means you have tension and gravity that is acting downward that are both contributing to your FC. So that means C is your answer. A 1.0 kilogram object moves in a circle of radius 2.0 meters of a circle with 2.0 meters at a constant speed. If the centripetal force is 8 newtons, what is the speed of the object? Fc is equal to mv squared over r. So we can use this to figure out. This object is 1.0 kilograms, and its radius is 2.0 meters. And we have a constant speed. V is equal to something that's constant. So then you just have v squared. We have to get v squared. So you can multiply both sides by r over m. So you can multiply this by r over m too, because that's just the reciprocal of the things we want to remove. So that's r, and then m cancels here. So v squared is equal to the root of fc times r over m. So then if you take the root of both sides, then v is equal to your fc times your radius over your mass. So let's just substitute in everything. You have 8 times 2.0, the root of all this, divided by 1.0, and that's equal to the root of 16. That's going to equal to 4 meters per second, and that's going to be equal to B. So you have a 1,200 kilogram car that travels around a curve of radius 40 meters. If the coefficient of friction of 0.50, what is the maximum speed before slipping occurs? So we're looking at a curve, actually. So inside of the curve, we're going to say it's like a circle. So this means we have a center here, and then we could expect the rest of our road to look like this. So our car is going to be 1,200 kilograms. Your radius here is going to be equal to 40 meters, and mu s is equal to 50 or 0.50. And we want to find when Vmax is. So when you have, before slipping occurs when you no longer have Fs. No more Fs, no more static friction acting. That means that you have overcome the barrier of Fs max. Overcome Fs max. So here, what do we have that is providing our centripetal force? So we have something here that is keeping the object moving in a circle. So your centripetal force is from your friction. Because we know that vertically, you have your forces of gravity, which is going to be acting down. You have your normal force, which is, so you have your object right here. You have your normal force up, and you have your force of gravity down. So your normal force is up minus your mg. So we know that this is going to equal to 0. So your normal force is equal to your mass times your gravity. So that means that you're in vertical EQM, and that means your acceleration in your vertical direction is equal to 0. But we know that in our horizontal direction, your acceleration is not going to equal to 0 because we're going to be moving. So we have something that is providing a centripetal force. It must be from the Fx. So we have to find what Fs max is. So that's going to be mu s times your normal force, and your normal force is equal to mass times gravity, and you can just substitute in. So we know here, this is going to be equal to, your Fs max is going to be equal to your centripetal force. So we're going to say that this is equal to Fc. And we know that Fc is equal to mv squared over r. So now that you have mu s times mg is equal to this, we can see we have m on both sides. You can just cancel that out. So mu s times your gravity is equal to velocity squared over r. So if you multiply both sides by r, you can just get that v squared is equal to r times mu s times g. And if you take the root of both sides, you get that v is equal to the root of mu s times gr. Now all you have to do is just plug in your values. So you have v is equal to 0.50 times 10 times 40, and that's equal to the root of 200. That's approximately going to give you 14.1 meters per second. So your answer here is going to be approximately B. Now, for a mass, okay, we have a mass is moving in uniform circular motion. Which of the following must be true? So we have a circle, your mass is going to be going in a circle. So that means whenever you have circular motion, you have a force that's pointing towards the center of your circle. So what does this mean? That means that you have to have an object that's moving in a circle, but it has to be at a constant speed. It has to be at a constant speed. So that means that the only thing that's changing is your direction. Direction is going to be constantly changing only. Changing, not your speed. Not your speed. And that means that your velocity is changing. That's because velocity is not only dependent on what the magnitude of your speed is, it's also dependent on your direction as well. So what's changing is your direction, which is just going in different directions with the same speed. So you have C. So a 0.5 kilogram object moves in a horizontal circle of radius 1.0 meters at 5.0 meters per second. What is the centripetal force? So you have your object here, your m is equal to 0.5 kilograms, and our radius is going to be 1 meter. radius is going to be 1.0 meters, and you're going to have a velocity that is equal to 5.0 meters per second. We need to find our centripetal force. So you can just use your FC is equal to mv squared over r again. Plug everything in, 0.50 times 5.0 squared, and then you divide that by 1.0. So that's all going to equal to 12.5 newtons. So that's equal to B. A roller coaster car goes over the top of a hill in a circular arc. At the top, what happens to the normal force as your speed increases? So we're going to say that this is our hill, right? So we're going to say that at the top of the hill, you have something that is going to be pulling it down. So you're at the very peak of this, and you can see that your hill is going to create a circle because it's a circular arc. So we're asked, okay. Yeah. So what is pulling it down? At the top of the hill, you're going to have two forces. You're going to have the force of gravity that is going to be pulling this object down, and it's going to be from the center of its mass. That's force of gravity. And you also have your normal force that is going to be acting upward, that is keeping it from going through the surface of the hill and like going down. So you have that. So we can use Newton's second law. F is equal to ma. So you have upwards, you have your mass times gravity, which is going to be your normal force. Or actually, let's just say we have our Fg minus our normal force is equal to ma. So your normal force here is going to be what we're going to isolate. So Fg, we can replace it with mg minus n is equal to ma. Here we have mass, but we're going to have velocity squared over r. And that's our centripetal force equation. That's Fc. So we have, if we isolate just n, that's going to be mg minus mv squared over r. So this means in this equation, as our mv squared over r increases, that means that n, your normal force, is also going to increase as well. Or your normal force is going to decrease. That's because you're subtracting it from that. So we're going to choose B, it decreases. So a conical pendulum consists of a mass that's moving in a horizontal circle. So our circle is going to be like this now. So imagine this is you. You're like, it's a conical pendulum. And let's say that it's being held from a point like this. So you have a mass like that. It's like moving in a circle and is going in like this direction. What force provides your centripetal force? So when you have this situation, you have your tension, but it's going to be at an angle. It's at an angle. And you also have your object is going to have a force of gravity, which is equal to mg, which is going to be acting downward. So you can actually break this, your Ft, because it's at an angle and it's not on the axes that are provided to us, that we're just going to assume here. So our Ft is on the axis, so we don't have to break that into components. But Ft is at an angle, so you have to break that into components. Like acting up, you have your force Ty, which is going to be equal to your force of tension times cosine of theta. And in the horizontal direction, you have Ftx, which is equal to Ft sine of theta. And that's going to be toward the center. You can actually see here. But we also have here you can label your Fc, because your Fc is always going to be pointing to the center of your circle. So that points towards your center. Your Fty is going to balance the weight because it's acting up. So actually, yeah, Fty is going to balance your weight. So that means that if we set up our centripetal force, we can say that T, or your force of your centripetal force, is equal to T sine of theta. So our answer is equal to the horizontal component of tension. Because you can see here, FTX is your same force. A satellite orbits Earth in a circular orbit. What provides the centripetal force? So let's say you have Earth here and you have your orbit like this. And we want to figure out what is keeping the satellite pointing into the center of the Earth and keeping it in the circular orbit. Because something has to be creating a force that is making it not drift out into space. So in this situation, you have no contact forces, you have no tension, and you have no air resistance. So you should know that it's gravity that pulls the satellite toward the center, because Fc is going to be equal to your force of gravity. And you have the equation that your gravitational constant times your mass, your first mass and your second mass divided by the radius between them squared is going to be your equation that describes this. So your answer is going to be C.